Hello, this is K.Sangeetha, Assistant Professor, EC Department, SNS College of Engineering, Coimbatore. So today we are going to discuss about a linear filtering and point operation. So let us start with the point operator. That is, point operators or in image processing and computer vision, the point operators are also known as pixel-based operations, or transformations that modify an image based on the value of individual pixels. That is, image based on the value of individual pixels without considering their neighbors. So these operations are called point operators because they act on each pixel independently, processing one pixel at a time. So the point operators are typically used to perform some basic enhancement. That is, it identifies the pixels and enhancement, that is thresholding, contrast adjustment, and various other pixel level transformations. Example of such operators include brightness and contrast adjustment, as well as color correction of and transformations. In the image processing, such operations are known as point processes. So this So a point operator is a function that maps an individual pixel value to an output pixel value. So types of point operators are brightness and color adjustment, contrast, gamma correction and thresholding, inversion, logarithmic transformation, power law transformation, and bit plane slicing. So the examples of point operator applications are image enhancement, image thresholding, image inversion. As a image enhancement, contrast stretching is used to improve the visual quality of an image by expanding the range of pixel intensities. And image thresholding, that is, thresholding is frequently used in image segmentation to separate objects from the background. For example, converting grayscale images into binary images for object detection or medical imaging. So the image inversion, negative image, often used in artistic effects for inspecting image properties. The advantages and limitations are it is simple and fast. Point operators are computationally efficient because they process each pixel independently, and they can be used for wide range of tasks like contrast enhancement, segmentation and noise removal. And the effects of point operators are easy to understand and control. The main limitations are point operators do not take neighboring pixels into account, so they cannot capture spatial relationship or details such as texture or structure, and they are not suitable for tasks that require analyzing or manipulating regions of the image as a whole. So the point operators are fundamental in image processing for simple and efficient transformation. They are particularly useful for tasks such as image enhancement, thresholding and contrast adjustment. However, for more advanced tasks that require analyzing spatial relationship between pixels and more complex operations like neighborhood based filters. And this is the histogram equalization. So the histogram equalization is one of the enhancing operation of an image. So it is widely used image enhancement. So the histogram of an image is a graphical representation of the image distribution of pixel intensity values. So it widely used image enhancement technique in image processing that improves the contrast of an image by modifying the intensity distribution. It works out by redistributing the pixel intensity levels in an image so that they convert the entire available range of pixel values. This process can be particularly useful for improving visibility of details in an image that may be too dark or too light. So these are some locally adaptive histogram equalization. The first one is original image, and that is histogram equalization is done for a particular area, and the full locally adaptive equalization is done in the picture C. And linear filtering, and the next one is linear filtering. So the linear filtering applies to a filter kernel to an image known as convolution. So the new value of each pixel is calculated as the weight of the sum of its neighboring pixel values determined by the kernel. So the locally adaptive histogram equalization is an example of a neighborhood operator or local operator which uses a collection of pixel values in the vicinity of given pixel to determine the output value. So the linear filtering in this operation, the figure f of xy is the neighboring filtering, that is convolution. So the image on the left is convolved with filter in the middle to the yield of an image on the right. So the linear filter is widely used technique in computer vision for manipulating on or enhancing images. It involves applying linear transformation using a kernel, that is filter. The h of xy is a filter to modify pixel values based on their neighborhood. So linear filtering is fundamental to tasks such as smoothing, sharpening, edge detection and noise detection. Hope this video will useful to understand the basics of linear filtering and point operators. Thank you.